All right, so today's notes are about the wind. We did an activity yesterday about prevailing winds, right? Okay, so let's write that down. Okay, let's write that information down. So prevailing wind. Prevailing wind, the definition basically is it is the most common wind direction in a band of latitudes. Do you remember that? Remember this this globe here with all of our arrows? Remember, in each band, 30-degree band of latitude, the wind went all the same direction, didn't it? The average wind. Now, was there ever a day where it didn't flow in this direction? Maybe. Maybe there was one month where it didn't. But the average was those directions. Okay? So, it is the most common wind direction in a band of latitudes. Okay, when I say band of latitudes, I'm talking those degrees clear across the world in that band, okay? All right, so then how do I get the direction, right? Well, remember your compass, north, south, east, west. All right, then you have your northeast, northwest, southwest, and so on. Okay, so what happens if my prevailing wind direction looks like this? What's the wind direction? Southwest, because it's in this corner, right? Southwest. Remember, it's from where the wind comes from, not where it's going, but where it's from, where it originates. So it would be southwest. What if it was like this? Northeast, right? Because it's starting in the northeast corner. Okay? I would say that's a common mistake, because a lot of people tell me where the arrow's going rather than where it's coming from. All right. So how does this affect the climate then? Well, what happens if your wind blows over an ocean? What's your climate going to be like?
Warm.
Keep thinking. Okay, remember, over top of an ocean, that ocean water is always like evaporating, right? So you have a bunch of water vapor, and that's normal, okay, just because of sunshine. So you have a bunch of water vapor that's above the ocean, and now here comes the wind. What's the wind going to catch with it? Yeah?
The water can be like sprinkling.
Yeah, so it's going to pull all that water vapor with it, right? So if your wind is coming from over an ocean, you're going to have a wet climate, because it's going to carry water vapor with it. Okay, what happens if your wind is blowing over a desert? Yeah, it's gonna bring with it a dry climate, right? Okay, and we could go on and on with more examples. Just remember that your wind is gonna bring with it wherever it's been. Okay, that's how it works. Okay, so now that we understand direction of winds and how it affects climate, let's talk about literally how does the wind blow? Why does the wind blow? Okay, it's the same as ocean. It's the same as temperature. Okay, so first of all, the bottom line is that wind is always going to blow from high pressure to low pressure. So let's write that down, and then we'll dissect that a little bit. Wind blows from high pressure to low pressure. And that is basically the golden rule. So now let's figure out, okay, what does that mean? All right, well, if I have a bottle, we know this bottle has air in it, right? Okay? If I squeeze the bottle or apply pressure to it, what happens to the air molecules inside?
Get closer together.
They get closer together, don't they? I'm literally squeezing them. Okay? So when the particles get closer together, they become what? More dense because they're closer together. What does something that's dense do? Sinks. Okay? And then the opposite, if I have less pressure, what happens to the particles?
They rise.
Why do they rise though?
It's less dense
It's less dense. Why?
because no pressure.
There's no pressure, so the particles spread out, don't they? So they're not as dense anymore. They become less dense, and what happens when you're less dense?
Rise up.
You rise. See how that works? Okay, so let's write that down. If it's high pressure, and when I say pressure, I'm talking air pressure, okay? High pressure, the particles literally get closer together, don't they? Because they're being squeezed. And when they get closer together, they become more dense. And when things become more dense, they sink. All right, now opposite happens when it's low pressure. So when there's low pressure, instead of the particles getting close together, what do? Spread out, right? Opposite. Your particles are going to spread out. So they're going to become less dense. Good job. And instead of sinking, they will rise. Okay, now let's talk temperature, because air has a temperature, doesn't it? You can have warm air and cold air. What temperature do you think high pressure air is? Why do you think cold, Memphis? Yep, because it's sinking, and we know cold particles get close together, don't they? They don't move as fast, so they get closer together. So high pressure air is cold. Low pressure air is opposite, right? It's now your particles are spreading out, so they're moving less fast, so they get warm. Or they're moving faster, sorry. Opposite, they're moving faster. All right, so this follows the same pattern as we've been learning before. Cold air sinks, warm air rises. Same as water. Cold water sinks, warm water rises. Okay? So you can put this in a picture if it helps you remember. This is what it's called, a convection current. We've talked about it lots of times. Okay, your high pressure is going to sink. Your low pressure is going to rise. That's what causes the wind.